All right. Hopefully this all works. All right. This is hacking CBC Botball Controller because it wouldn't be a Botball controller if it couldn't be hacked. One sec here. Okay. I'm Jeremy Rand from Norman High School. Matt Thompson, where are you? You might want to stand up. You helped with this. You get some credits. Yeah. And Braden McDorman from Norman High, Matt's from East High. Okay. Braden McDorman from Norman High was not able to be here, so he deserves credit too. So if you see him at Texas, please do if you like this. All right. Now, first off, I'm going to show a little disclaimer so that I don't get sued if someone gets mad at me for what I'm presenting here. So, all right.
The following experiment is dangerous for your safety and the protection of those around you. Do not try this at home. No, really, don't. This tightly wrapped package with a wire in it is 20 grams of gunpowder. First discovered in China in the 9th century, it's thought alchemists stumbled across it as they tried to find the elixir of immortality. We do these experiments so you don't have to. Do not try this.
Okay. Everybody likes exploding microwaves, right? Okay, so this paper, if you follow it, it won't burn down your house, but if you incorrectly modify the software line your CBC, you've got a chance of breaking it, and that would be bad. So why is it dangerous? Well, it's much more dangerous than the XBC, which I covered last year, because the XBC has a bootloader, which is completely untouched by the firmware update process. And even if you somehow manage to screw up the bootloader, you can buy a C-BOD cable for $10. It'll fix your XBC. And so it's pretty safe to mess with your XBC. The CBC does not have these safeguards. The bootloader on the CBC is a file called userhook0, which sits on an internal flash drive, not to be confused with userhook0 firmware updates. And that thing is updated every time you update the firmware. And if you give it a bad firmware and you corrupt that userhook0, you're going to need to mail your CBC and Kipper for repair unless you feel like taking apart the CBC and getting to the internal flash drive that's there. Okay, so why would you do it if it has a risk of screwing up your CBC? Well, okay, you can add new functionality for CBC libraries. You can learn more about the functionality already there that Kipper didn't tell you about. It may help your Botball team do better. It may prevent you from having to constantly email Kipper with feature requests. Because once I found this, I noticed that my level of email traffic between me and Jorge went down about threefold. So Jorge's probably really happy that I started doing this. It may give you something to put in your resume, make you a topic for a GCER paper, and hacking stuff is just fun. If you disagree with that last statement, this may not be for you actually. But if you like hacking stuff, this is for you. Okay, CBC architecture. As you may remember from GCER 2008, when the CBC was originally announced, CBC originally stood for CBC Botball Controller. The name was later changed to the recursive acronym CBC Botball Controller because I guess Kipper didn't have permission to use the CBC trademark. What's a CBC? Well, it's this thing. Really weird looking, souped up alarm clock. No kidding. The CBC is technically an embedded platform featuring a 350 MHz ARM9 processor. For comparison, GBA from last year is 16 MHz. The CBC is way faster. 64 megs of RAM. The GBA had 256K, so way more there. 64 megs of flash. XBC had 4 megs, I believe. 320 by 240 touchscreen. Speakers, audio output microphone, 2 USB 2 ports, Wi-Fi, accelerometer, and honest mics. The CBC is a heavily hacked CBC. So that means, well, it looks quite different. It's really similar under the hood. So it storms Linux, and just about all the official CBC firmware is still on all of your CBC. It's just sitting unused mostly. This means that, like the CBC, it is very, very hackable. Okay, what's different between a standard CBC and a CBC? Obviously, something's different, or they wouldn't have renamed it. The CBC added a coprocessor board. It's called C-BOD, which stands for CBC Breakout Board. I'm not sure exactly why they named it C-BOD. That sounds like an odd acronym. Kipper likes to just call it the BOD, I guess that's easier to say. Okay, C-BOD handles motors, sensors, servos, and then serial ports. The camera is handled entirely by the chumpy. C-BOD is pretty much completely closed outside interference. The only way you can load new code onto C-BOD, at least for this year's CBCs, is disassembling CBC, accessing a secret JTAG connector on the inside that's on the C-BOD, and this is a really good chance of bricking your CBC. It'll obviously avoid a warranty. Kipper will know that you screwed it up. They will not fix it for you. So we decided not to touch the C-BOD this year. Next year, they're supposedly going to have a bootloader, which will make it way safer to mess with, and we'll try that out. Other differences between the CBC and the chumpy: the internal Wi-Fi USB card on the chumpy was replaced by a 1 gig USB flash drive. So that's why you don't see any Wi-Fi on your CBCs. There's no Wi-Fi card there anymore. And that's also why you have 1 gig of flash rather than 64 megs that the chumpy normally has. The chumpy's accelerometer was moved to the C-BOD. That means that if you try to use a chumpy accelerometer driver, which has way more features than Botball, I hope Botball adds the chumpy features in the next version, the chumpy driver will fail, which is really annoying. We spent like a week trying to make that work, and we finally noticed that it was moved to the C-BOD, and that was very frustrating. Okay, so here's another tip here. If you're going to be hacking the CBC, you need a Linux-like system. If you're on Windows, Charm Lab has a really nice Sigmund installer. It takes a few minutes to set up. There's a link in the paper, which is on your proceedings flash drives. Okay, so the first thing we did when we started to hack this thing was we wanted to figure out what format the firmware updates are in. Firmware updates are in a file called userhook0. Now, whenever I see a file, I don't know what the heck it does, I open it in a text editor just to see what it looks like. Here's the first few lines when you do that. Okay, so obviously it's readable, and if you use Linux at all, you'll recognize this because it's a shell script. Yeah. So that's interesting because that means we can mess with the shell script and possibly change what the firmware updates do. So yeah, we can figure out how it works. Now we looked at the user shell script and noticed a few lines that look like this. There's more lines in this that does this, but these are a few. As you can see, there's some command called extract, and there are some numbers. Now that looks a lot like addresses and lengths of data blocks. And if you scroll down to userhook0, you see a bunch of random binary data. So it looks like, okay, are those offsets for those data blocks? Now to check that, we took the last of those numbers and added the start position and the size, and we get the total size of userhook0, so that confirms what we were thinking. So all the data in userhook0 after the shell script is those data blocks. Now, there's a few data blocks that I thought were really interesting looking because of their names, which end in TGZ. That just happens to be a compressed archive format that you can extract with WinRAR, or 7-zip if you like that. I use WinRAR, but 7-zip is awesome too. So we use the Linux command split cat on userhook0 to remove the data surrounding those files, and we got the two files themselves. Now, the details of what commands we used exactly in the paper, but it's fairly straightforward if you know how those commands work. So we extract them, we actually got some usable files. VFAT contains some initialization boot script, and the webcam driver, and a few other drivers. ext2 contains all the KISS-C files, so that's useful, because now we can analyze how KISS-C is set up. Okay, so here's a fun little feature that is in the C language, which you may or may not know about. The CBC runs Linux. You have access to a bunch of really nice Linux functions. The most useful of these is the system function, which executes just a single shell command. So, if you want to reboot your CBC with one C command, type system reboot. That's all you have to do. That reboots your CBC. You can build a lot of shell commands, so the system is really nice. Okay, so rather than list all of the source code in the paper itself, we produced an installer, which you stick on a flash drive. The installer is in one of the files that is in your proceedings disk. You stick this disk into the CBC, run robot.save, it'll install all of our mods that we've made. Now remember, we think it works, we use it on our CBC all the time with no problems, but if it should result in ultra-realistic smoke effects, Kipper will not fix it, we will not fix it. Don't complain to us, definitely don't complain to Kipper, they're not involved in this. They will not be pleased if they get a bunch of people complaining about this. Okay, so network support. The Chumby has drivers for some USB Ethernet and Wi-Fi, and the drivers are still on the Chumby, even though the actual Wi-Fi card is disabled. Modifying the boot script that Botball produced can actually make these adapters connect your router on boot, and that's really nice. This lets your CBC and PC communicate. Now, why not? So you'll need a USB to network adapter of some kind, either Wi-Fi or wired Ethernet. Now, why not just use USB? Because, I mean, that's already there, right? Well, the USB cable on the CBCs runs at about 4.8 kbyte per second, because it's just a serial chip with a USB converter on it. So 4.8 kbyte per second, you know how much we get with Wi-Fi? Even when it's wireless, we get 500 kbyte per second or more. So, if you'd like to download code 100 times faster, because C can be pretty slow to download your code sometimes, this is really, really fun. And of course, Wi-Fi is wireless, so you don't need to carry your bot back to your computer every time you download a new program, because that was really a bother to us before we found this. So our installer set this all up for you. Now, once your CBC is connected to a LAN, you can get a shell prompt from an SSH client, that's a secure shell. This gives you an interactive command prompt where you can mess with some of these files at will, which is really nice. Here's a security warning though. Don't leave your CBC connected to a network with users who you don't trust, and especially never put it on an unencrypted Wi-Fi network. Actually, I'm doing that right now because my router broke, but don't tell anyone. Because it's trivially easy for a cracker port scan to find the CBC's IP address, SSH into it, because the CBC's SSH is not the password, and then cause problems. They could break your CBC quite easily if they were trying to. They could steal your code, or who knows what else that I can't imagine because I'm not that evil. Yeah, so if you're putting it on a wireless network, make absolutely sure you're using encryption. Okay, so shell scripts are also available for network downloads of programs. So you just type in, from the directory where you install this to on your PC, you type /download my program. The / is a Linux thing for those of you who are to Windows. You need to have that at the beginning of most of your commands. And the program's called my program will be downloaded to your CBC. Really simple. Under the hood, the script uses tar to compress your program's files into one big archive, transfers it to your CBC, and then extracts it to the appropriate directory. So you get multiple files, including .text, .jpeg, .mp3, just FTC files. Any file type you want will work with this. So, yeah, that's fun. If you have a file that isn't part of the program, you just want to get it onto your CBC's flash for some reason, we have a shell script for that. We use the secure copy command. We have a simpler script that retrieves data from the CBC's flash. So that's really nice. Let's say you have code that wants to dump some data. With IC, we use the upload array. Well, KISS doesn't have that. But with this, you can just dump your data to a .text file and SCP it back to your PC using a script, which is fun. Okay, so debugging and interacting with code via GDB. Botball students had kind of a love-hate relationship with interactive C. I mean, the thing was slow, it was inefficient, it was weak, it couldn't do anything properly. It crashed all the time, but it did have this really nice feature that you could rapidly debug code just by typing in a command and having it execute immediately. KISS C scrapped that in favor of the speed, efficiency, and power of NCC. Did they? Linux has its own debugger with interaction, which is GDB, GNU debugger. You can access it using a shell script we provide. And let's see, I'm going to try to show a demo here, so bear with me while I see if this is a cooperative move here. Let's see here. Let's see. I think it's being a cooperative. That's too bad. Yeah, here we go. Okay. This Wi-Fi is apparently very laggy, so I apologize for going a bit over the time limit here. I'm sorry. Okay. Okay, so I've just told it that we're going to debug a program called blank, which is just basically sort of like the IC libraries with no other functions. So if you just want to test your C library, you use the blank program, which I provide. So we're at GDB prompt now. Now to run the program, it's called blank. We type run, and it's saying blank program, press B to exit. That's actually what would show up on the CBC if you ran it from there. Now to get out of the program and pause it so we can run interaction and we can control Z and we get a GDB prompt again. Now let's say we want to run a function. Let's say we want to turn on the motor. FD 0. And I need to put down the microphone so I can hold this boss and just jump off the table. So hang on a sec.
I think it worked. Put it on the floor.
It's lagging again, I know. It's lagging, so yeah, let's see if it works. Uh-oh, that's not good. Well that's very unfortunate. Make sure we sit right here. Obviously I screwed up when I set it down there. Okay. Sorry about that. Oh well, but it would have turned on one of the motors. Yeah, sorry. Okay, let me get a pop back there. Let's see if we can actually get back into it. And if it doesn't work, I don't know. I'll reboot it, but I'd rather not. Because I don't have that much time left. Okay. I'll let that run for a little while. I'll go back to the PowerPoint. Okay. The CBC's GUI uses the Qt library. Qt is this really nice plugin available, which Braden McDormand compiled on CBC. And it basically lets you run remote desktop using VNC to your CBC. So, if you like using your PC screen and mouse, but instead of a tummy touch screen, you can actually control your CBC remotely. I'm using this works with the internet, not just through a LAN. So last night, Braden in Norman was actually connected to my CBC through VNC, and it was lagging for him horribly, but it did work. So he was playing around with that. And okay, we're going to see if we can actually get a demo of all working here. Okay, I think something. Okay, let's see this. Okay, we actually do have VNC up here. This is the camera screen. Right now I have the quality really low so that we can try to make the frame rate faster. I know it doesn't look much like the real thing at the moment. It's because my network is lagging. You can control the image quality of the VNC. But let's see here if it works. Okay, so I just hit X, and it's slowly loading the main screen again. Usually it's a lot faster than this. I think this public Wi-Fi has a weaker signal than I usually use. But yeah, so you can click around and wait for it to load again, because it does that. So sorry this isn't working out perfect. Oh well. Alright, so you've seen that, okay. Now, oh there we go, it's loading. Okay, let's go back to PowerPoint. Alright. Now, okay, fixing the camera frame rate. This is really nice because, okay, you know how the CBC webcam only gets about 3 or 4 FPS on a good day? Well, okay, that's because the auto exposure control is enabled by default by the camera driver, and for some reason this particular kind of camera makes the exposure ridiculously long, like absurdly long. That's why you only get 3 or 4 FPS. So, this lowers the frame rate, and it also causes this really bad motion blur, which screws up the color treatment horribly. So here's 2 lines of code, which will actually fix the camera. Just type that into a C program. What we're doing here is we're editing the settings in the video driver. We're disabling auto exposure, and we're forcing exposure to 0, which I guess is the minimum. It doesn't actually see exposure to 0 milliseconds, whatever it should be, but I don't know. 0 seems to work, so we stuck with it. And I would show a demo of that, but seeing as it was lagging by on the VNC, I guess I can't really show you the camera frame rate increasing, because it would still lag. So, sorry, but we get up to about 11 or 12 FPS once we've done this, and there's no motion blur. Okay, binary caching. This saves a lot of time. Okay, you know the CBC Firmware 1.0 finally allowed you to store multiple programs? Well, okay, you have to recompile it each time you switch programs. That's inefficient, because some programs will take 30 seconds to compile. Do you really want to spend 30 seconds just switching programs? Or if you click the wrong one, you have to wait for it to compile and go back and hit the other one once you realize it. That's inefficient. So we fixed it. When we compile a program for the first time, we cache a binary in the program's folder. Next time we hit the compile button, the CBC checks that folder first. If the binary is already present, the program is not recompiled. The only time we'll actually recompile your code is when you re-download it. So that speeds things up immensely. And we're going to see if I can do a demo with that via the VNC. Let's see here. We're going to see if I can drag that down.
Use your presentation.
Okay, come on. Please work. I really hope this works. Okay. Well, okay. We're gonna wait for that. A few slides ahead. We'll see if it decides to work. All right. Okay. Programming in C++. The 0.6 firmware, which I believe only the Oklahoma region got, contains G++, which is a C++ compiler, as well as GCC. The higher versions of the firmware removed it to save space. But if you have the old file, you can put it back, just like copying it to CBC. So we did that, and we also had to copy over a few libraries that were removed in later versions. And we modified a compile script to call G++ instead of GCC. And once we did this, we could compile C++ programs. So if you prefer object-oriented programming, but you want the low-level access and speed and efficiency of C, then this is something you might like. If you want object-oriented programming, but you want it to be simpler than C, then you want Java, which, that's possible too. We'll find out that, I guess, later today in another talk, but yeah. Okay, images and music. This is just a fun little thing to play around with. I figured out. You can display JPEG and PNG images on the screen while your program runs. Your code can also play MP3 songs. Just add the image or song to the project folder that the download script is copying, and you use one of the system commands that's in the paper, which are kind of long, to make it work. And yeah, that's really cool, actually, because let's say you have a checklist or something that has an image in it. You can make the CBC display that image. You don't need to carry on a piece of paper that has a printed image, which is kind of cool. Not sure if people would actually use that, but whatever. Okay, dimming the screen. We're finally getting toward the end of this presentation. I know I'm probably over the limit by now. Sorry. If you want to save battery life on the CBC, you can lower the backlight, as was discussed already. I'm beaten. Okay, so yeah, you have 16-bit resolution when you're doing that, and yeah, it saves a little bit of battery. It doesn't save a whole lot. We didn't see much difference really, but I don't know. Maybe you're in a really dark room and you don't like it overwhelming your eyes. I don't know. It's cool. Okay, what else can be done? The stuff we did over the past 6 months, it's really not that much. There's going to be a lot more cool stuff that's going to come out in the next year or so, I'm guessing. Fun stuff we have not discussed yet include the vision algorithms and the frame grabbing in the firmware. Like maybe you want to check the average color for the camera image. I mean, that would be kind of fun, and that's pretty simple to do, we think. You just haven't gotten to it yet. Maybe you want to change the motor controller on the actual C-BOD. Once I get the bootloader for that, that'll be really easy. Because fixing the i5 motor would actually be probably quite easy if you have access to C-BOD source code. Because, as I understand it, and I hope I'm not wrong in saying this because I'm not an expert on the i5 motors, but what I'm told by Kipper, the i5 motors like to draw a lot of current when you change the velocity quickly. So if you want to change the motor controller on the C-BOD to sort of smooth the motor output values on the i5 motors, you can actually probably use closed loop control with the i5 motors and not need to mess with the PID gains, and definitely not need to space them apart. It's a much harder solution that might work better, so if you want to try it on the C-BOD, I'm curious to hear if it works. And cross-compiling for the Chumpy on the PC, which works kind of for us, but we can't get it to work on Windows, only Linux. and I'm on Windows using Cygwin, so I can't test that. But yeah, that's way faster than compiling on the CBC itself. Okay, so you can contact us on community.botball.org. We frequent both the chat room and the forums. And I guess I'm going to open up the questions now.
We actually have run a little bit over, so we don't have time for questions for Jeremy. But
Okay.
Jeremy, will you be available to answer questions after this?
Can we just hang out over there?
He's supposed to
What's the
get
talk?
on
Oh, yeah.
So if you run into Jeremy sometime later, you can ask him your questions.
Okay.